Okay, today we're going to talk about voltage, which is going to lead us into circuits, which is going to lead us into Ohm's law. We got to talk about what voltage is. Voltage is a very similar concept to electric field in that it is the potential for something. Electric field was a potential for a force. Voltage is the potential for potential energy. All right. What that means is, remember how electric field was the force per coulomb, measured in newtons per coulomb? Voltage is the energy per coulomb, measured in, well, joules per coulomb. Now, what's interesting is that this is electric potential energy, which you remember we talked about previously. Electric potential energy, when you have two individual charges, was K, Q1, Q2 over R. Did we talk about that? We might not have talked about that. Not the end of the world. We don't need to worry about that, because we don't care about this part. We care about this part. So, voltage is really simple. It's energy per charge. All right. We're really more interested generally in the idea of how energy is connected to voltage and not generally the other way around. Just like for electric field, we were generally more interested in the force being connected to the charge times the field. All right. I like to think of voltage as potential energy, which is really annoying. But if we use an analogy, it'll make sense. Think about gravity. On the ground, an object would have 0 joules. Is there anything necessarily on the ground in this picture? No. So it's 0 joules per kilogram. Every kilogram I put there is going to have 0 joules. If I go up a meter, every kilogram is going to have 9.8 joules per kilogram. There's nothing here, but it has the potential for potential energy equal to 9.8 joules for every kilogram. If I go another meter up, how much energy am I going to have per kilogram here? Yeah, that's right, 19.6 joules per kilogram. If I put 1 kilogram here, it's got 9.8 joules. If I put 2 kilograms here, it's 9.8 joules per kilogram, 19.6. 1 kilogram here, also 19.6. 2 kilograms here, and twice that. I like that pictures look the same. So there's our idea that it's this potential for potential energy. Just like gravity, we can talk about voltage, the same idea. Let's look at some spots. Point A, point B, point C, point D. And just like we can say, oh, these things are based on that. Now, with voltage, we can't really talk about the distances. We can, but it doesn't really derive just like gravity does. There's no MGH here. But we can just say, oh, this is plus 10 volts. This is 0 volts. This is minus 10 volts. It's energy per coulomb. 10 joules for every coulomb there. Negative 10 joules for every coulomb here compared to 0. All right. That's our key idea. We're compared to some arbitrary 0, just like the ground was an arbitrary 0. All right. So if I put a positive at point A, what's it going to try and do? Well, if I put a kilogram at 2 meters, what's it trying to do? It tries to fall. It tries to lose that energy. This thing's going to try and do the same thing. It has energy. It's going to try and lose that energy. trying to lose that potential energy. Where's it going to go? It's going to change the kinetic, just like it did before. There's nothing new here. What about if I put a negative at point B? What's it going to do? Is it going to try and go toward C or toward A? Think about it for a second. What it's going to do, it's still going to try and fall, but it's going to try and fall towards A. See, unlike gravity with one kind of mass, electricity has two kinds of whatever it is, where we have positives try and go with the field, negatives try and go against the field. A positive here has a lot of potential energy. A positive here has very little. But if you come back to this potential energy is equal to Q times V, if Q is positive, well, then it acts normally. If Q is negative, we have to deal with the backwards part of it. All right? That's part of this big thing with voltage differences, that it's kind of difficult to talk about. We have to deal with positives and negatives being different things. All right. Let's try an example. I would like you to figure out for me, what is delta U if a 2 kilogram object with 2 coulombs of charge, positive, moves from point A to point C. Give that a shot. We'll check in next